So in the previous video we have created our model for image classification using CIFAR-10 Dataset. Now coming to next part, in which we are going to create the GUI application for the same, that is that image classification neural network model. So now for that I am going to use Tkinter. So let's start. But before starting the coding part, just make sure that you have downloaded that model.h5 file in your PC. After that, create an empty Python file with which means create a file with extension .py. I am going to use VS Code IDE for the coding purpose. Now coming to the coding part. First of all, we need to import some libraries. As I had said, I am going to use Tkinter for the GUI. So first of all, we will import Tkinter and give it some alias. I am giving it tk. After that, we will import file dialog from Tkinter, which I will describe later that why we have to use file dialog. And then second library is PIL, which will be helpful in image manipulations, and then NumPy in case we have to deal with pixel values of images. After that, now very first thing in Tkinter is to initialize the GUI. For that you have to just call the constructor, or you can say create the object of tk class. So I am going to use top is equals to tk.tk. After that, set the height and width, or you can say parameters of our GUI application using .geometry method. Then we will assign it a title, like I am choosing image classification model, and then we have to configure every single object in Tkinter. In configure it, we can assign some background color. I am going to use CDC DCD. It is just similar to gray color. After that, we will assign a heading. For heading, we will create an object of label class, which is also present in Tkinter. So for that, label brackets. First of all, we have to define that of which frame this belongs to which frame. So we had actually created top object, so top, then text, that is what should be the heading. After that, padding, you can configure it as on your own. Then font values. After that, again configure the heading part, that is background and foreground color. I don't want to make my GUI model odd, so I am going to keep its background color same as the top object. And for background, you can choose any color. After that, pack means I have packed this heading with our top objects. Now just check, our heading was perfect. Now coming to next part, we have to create an upload button. So for that, we will create an object of button class. Again, we will define to which frame it belongs. Next is text, that is text of the button. After that, the third is command. The command defines that what function needs to be performed when this button, that is upload, will be clicked. And after that, again upload.configure, where again background color and then foreground color. And then, as I said, everything needs to be packed, so we will use upload.pack. For now, I have left that command parameter empty, so it's not going to work, but let's just see. We will declare it later, but we need some more objects right now, that is uploaded image part. For uploading for that image part, we will also create object of label class, and for that we will not configure it, we will just pack it and assign it that you have to reside in the bottom, and it can expand, so it is expand equals to true. Again label, that is label, here label object means the class of the image which our model will predict, and everything will be same. Configure and dot pack. If you will try to run this program, the last two objects will not be shown. So firstly, now we will assign the command to our upload button, that is upload image. And as you can see, it is saying undefined variable, so we have to define what upload image command is. So we will create a function def upload image. Now in upload image, when the upload button will be clicked, we have to show a pop-up so that we can choose what image to upload. So for that we will use file dialog dot make open file, and then when the image will be chosen, it will be stored in file path. Then we will create uploaded object in which we will store the file using that image dot open file path. After that we will convert that image into thumbnail with the help of function, that is dot thumbnail. It is provided in PIL library. And then image tk, which is also a function in PIL library for creating again image from the thumbnail. And then we will configure our sign image object which we have created earlier, and we will assign this image to that sign image object. And now after that, when the image will be uploaded, we have to configure our label, that is because currently we have not classified this image, so the label will be empty. As you can see, when I have clicked upload image, I have an pop-up. So now I am choosing a downloaded image that I have downloaded earlier. You can see when I clicked upload image, no label is shown. So now next, when image is uploaded, I want to show a classification button, that is classify button. For that I am again going to create a function, that is def show classify button, and the path of the image will be passed as a parameter. So now for classify button, we have to again create an object of button class from Tkinter, and everything will be same: the frame name, the text, the command. Again I am going to leave this command empty for now, then paddings, and again after that classify button dot configure, as we always do with every single object. And then our last thing is to pack this classify button with our top, that is our frame. But what will happen if we create the classify button? When we click on our classify button, we want that our model should be initialized and it should predict to what class this image belongs. So this is empty for now. Now we have to create a function, that is classify. Now classify, we want to load that image which is on that particular file path. After that I have to resize that image, because as we have seen in CIFAR-10, every image is of 32 by 32. And after resizing, we will expand the dimension of this image, that is actually an array of pixel values. So expand dim will increase the view in axis with respect to axis 0. After that, again convert that image into an array value. Then we will pass this image to our model, but we have to declare our model first. So I'm just sending that to do. Now we will have to import the model from Keras library. So for that, from Keras dot models, import, load model. And for that we should have that .h5 file in the same folder, so that we don't have to configure the path of this model in order to load this. So for that, model equals to load model, cipher model saved .h5, because that was the name of my model. And then we will declare the classes in form of dictionary. You can find this 10 classes, you can find the name of these 10 classes in this same order on the official site of CIFAR-10 Dataset. And because our neural networks only gives output in numbers, so but we want them to give output in a string format, that's why we have to create a dictionary. So aeroplane, automobile, bird, cat, deer, dog, frog, horse, ship and truck. Make sure you have written all these names in this same order, because this is what our CIFAR-10 model will predict. Now coming to that to do part again, we will pass this image to our model using model.predict. And as this the model will return a number, or you can say an int value, so we will convert that int to the string using our dictionary. And then just for debugging purpose, I am going to print that sign, and after that I will show this same label on my frame in the label object. Okay, I think okay, we have to define that what command our classify button will perform. So for that I'm going to use lambda functions. So lambda, classify and file path. Now I will run this, upload image and classify. Okay, something is missing, wait. Okay, for resize purpose we have to pass this 32 by 32 as a single parameter. So for that one more parenthesis will be there. Now let's again upload image one more time. And classify. So as you can see, it is predicted truck, which was actually. So this is from my side. That's all. Thank you for watching, and if you like this video, please like, share and subscribe.